from the office of my dad, and Bailey is there for moral support, and she's laying there on the tile having a nice rest. And now we are going on to 6.2.4 for 7th grade, titled How Can I Represent It? I have my new colored markers that I got from the classroom, so I feel very fancy. Okay, in the last few lessons we used algebra tiles and equation mats to solve problems in which variables represented specific numbers. The tile and equation mat tools are related to the processes you have used to solve word problems in which a specific value is unknown. Today you will connect these two tools and the expressions you wrote using a part of the 5D process to extend your repertoire for solving problems. So we're gonna get back into the 5D process today, but we're trying to kind of wean off of it if we've been reliably using it. I know some of us have strayed away from it, but those of us who are still using it, we're gonna try and kind of let go of some of it and get more into the symbolic algebraic representation rather than the 5D process, the whole table and the trials. So what we're gonna do for 6-93, it says the 5D process revisited. It says use the 5D process to set up the following problem, complete only 3 trials. Even if you do not yet know the solution, wait for your teacher's instructions. So if you're doing this before watching the video, which you should be doing, so do all the problems first, try them all out, and then watch the video. Only do 3 trials first, and then we'll go from there. So it says, I have a lot of reading, here we go. The Great Lakes contain the largest amount of fresh water on the surface of the planet. Combined, the 5 lakes, Superior, Michigan, Huron, Erie, and Ontario, contain 84% of North America's and 21% of the world's surface freshwater. It's interesting. The amount of water, here we go, here's the information we need to know. The amount of water in Lake Superior is 1,720 cubic miles more than the amount of water in Lake Michigan. So I'm going to start writing some stuff down. So I know, and this is kind of the describe, draw part. I'll write that really small right here. If you remember the 5Ds, we describe, draw first, so you put bullet points, kind of underlining the most important information. So Lake Superior, and I'm just going to put Lake Sup, because I don't feel like writing it all down, and it doesn't really matter, is 1,720 miles more than the amount of water in Lake Michigan. So it looks like we're kind of revolving around Lake Michigan, but I'm going to read the next sentence and double check. Lake Huron has 330 cubic miles of water less than Lake Michigan. If the total amount of water in the 3 lakes is 4,930 cubic miles, how much water is in each length? So a lot of information, but here's what I put first. It's Lake Superior is 1,720 more, more than Mich, and that's for Lake Michigan. I'm just trying to save space. What else do we know? Lake Huron, so Huron has 330 miles of water less than Mich. So Michigan minus 330. And the total amount is 4,930 miles, cubic miles, which would look like that. How much water is in each lake? Oh, you're stealing.
Sorry.
He's stealing my black and red whiteboard markers. Good thing I have all these ones. Okay. The total is there, and it wants us to figure out how much water in each lake. So that would be the extent of my describe draw. If you want to draw the lakes, that's fine. I'm not the best drawer, and we all know that. So I'm just going to leave it like that in bulleted notes. So that's describe and draw. Now we need to make, we need to make our chart. And we've seen this before. I hope we remember. It wasn't that long ago. So here's our define, here's our do, and our decide. Okay, so here we need to define the variables, and I remember some of us, when we were doing this in class, they were saying, well, I'm going to choose this thing as the variable because everything seems to be revolving around this one part of the problem. And what I'm noticing is we're kind of revolving around Michigan. We don't know anything about Michigan, but we know that Lake Superior is that much more than Michigan, and Huron is that much less than Michigan. So we are going to define, I should have made the define section a little bit bigger, and I'm going to, because we have 3 things to account for. So we have Lake Michigan, and I'm going to put Michigan. We have, I just did Huron next. Huron, it's gonna be a tight squeeze. And Superior. Okay, so then we need to, for the do part, we're add all lakes together. And then our decide was, is it 4,930 altogether? And now that's going to be the start of our chart. I'm going to do my trials in a different color. Yeah, let's do that. Okay. So I'm going to define Michigan. Now it's time to define the variables. So Michigan is going to be my X, and we've been using X more than any other letter. So X is Michigan. Now Huron is just Michigan minus 330. Then Superior, we know, is 1,720 more than Michigan. So we are going to add, whoops, that's 20. There we go. That should be 1,720. Okay. So now I'm going to make my little line, because now we've defined our variables. So now we need to, for the do part, we just need to add all of these together. So this is one part that we need to add, X. Here's the next part we need to add, X plus X minus 330, plus this one, X plus 1,720 equals, and then 4,930 again. So now we're ready to start our trials. Actually, I'm going to keep this for your trials. So here's what I did. I picked a number that I thought might work, and I picked 1,000. And so now I'm just going to plug 1,000 into my expressions that I made. So 1,000 minus 330 was 670. And I did this all beforehand. And 1,000 plus 1,720 was 2,720. So now adding them all together, I got 40, no I did not, I got 58.90, too big. So 1,000 was, sorry, I'm looking at, it was 49, it was 43.90, sorry, I'm looking at my second column. So that was too small. Sorry. 1,000 was too small. That makes a lot more sense. Okay, so I did all that work beforehand, and I'm just looking at my paper now. So 1,500 was my next guess, because I knew it needed to be bigger than 100, or I mean bigger than 1,000. So 1,500 minus 330 was 1,170. 1,500 plus 1,720 was 3,220. And if we add them all up, we get the 58.90, and it was too big. Okay, we've done 2 trials. We can only do 1 more because the problem's only making us do 3. So I picked something kind of in the middle, because this was pretty big, this was pretty small. So I did something in the middle that was easy. 1,200. Whoa. So 1200 minus 330 was 870. And 1200 plus 1720 was 2920. So if we added these, I got 4990, which was too big. So there's my 3 trials that I did. And now there's actually something we can do so that we don't have to go through so many trials, because this would take us quite a long time to get all the trials done. And we can use what we know now about algebraic equations to solve it using just our algebraic equation that we made up. So I'm going to take this out of the table, and I'm going to erase the table. So I'm going to take that equation that we made in the table, and it was x plus x minus 330 plus x plus 1720 equals 4930. So there's our equation that we can actually start to combine like terms and start solving for x, because if we solve for x, then we get our solution. We get how many miles of water is in Lake Michigan. So let's start combining. I see 3 x's that we can combine, so I'm going to bring those all down to 3x. I'm going to add in what we have left. Okay, I see another thing that we can combine, these 2 values, so 1720 minus 330, that's all that means. So it's negative 330 plus 1720, which just means subtract. Keep the sign of the higher number. So 3x comes down, 330 minus 1720 was 1390. And we need to get the x by itself on the left side, so I want to get rid of this 1390. And if we do that on one side, we have to do it to the other. And that came out to 3540. This did. And 3x equals 3540. Last part is you want to undo the multiplication by dividing both sides by 3. And x is left on the left, and 1,180 is left on the right. So that is our solution that we could have tried to come up with the trials, but it probably would have taken us a long time to get here. So it was a lot simpler to take the equation that we made up to get our Lake Michigan. So now if we declare, here's our declare part. Michigan has 1,180 cubic miles of water. I'm not going to write of water because I don't have enough room, but I'm just going to leave it at that. Michigan has 1,180 cubic miles. What's the next one? Superior, let's do Superior has, and we have to actually calculate this right now, is 1720 more than Michigan. So you just add this to 1720, and I got 2,900. And the last one was Huron. And Huron was 330 less than Michigan. So I did the calculation, and it was 850. So there is problem 6 dash, oh my gosh, I moved it, sorry. 6 dash 93. And it says, does the total volume of the 3 lakes seem reasonable? And It does, because Superior has the most, Michigan has the middle value, Huron has the least, and that makes sense. Okay, moving on. To 94. I'm going to use that color again. 694. Okay, go for the gold. As you saw in the last problem, sometimes organizing your thinking using the 5D process to solve a word problem involves a lot of work. Sometimes the tables are very complicated or the numbers require many trials to find the answer. How can your new equation solving skills help you solve word problems? Read the following word problem and then answer the questions below. So here's our word problem. While looking at the country of Jamaica's results from the 2008 Beijing Olympics, Gemma noticed that the number of gold medals Jamaica received was twice the number of silver medals. She also realized that Jamaica received one fewer bronze medal than silver medals. Altogether, Jamaica received 11 medals. So in your book or on your computer, it says for part A, Gemma started by setting up the 5D process table below. What did she define X to represent? So I'm just going to write this down just so it's visible. Okay, so she had 3 columns: gold, silver, I'm going to put BR for bronze. So it looks like she put total number of medals, and then she put 11 question mark, because that was the total. So the number of gold she put as a 2x, silver she put x, and bronze she put x minus 1. So part A says, what did she define x to represent? So if we look at our table, there's only one part of the problem that was assigned just x. And we can see, because it's nicely organized, that silver is our x. So x represents silver medals. And that's part A. Part B says, how did she represent the number of gold and bronze? So for gold, I'm looking at the gold column, she represented gold as 2 times x, or 2x. 2x is gold. And then for bronze, she represented it as x minus 1, because that said in the problem that bronze received 1 fewer than silver. Fewer means less, so x minus 1 is bronze. Okay, so now it wants us to write our equation to find the total number of metals. So like we did with the lake problem, these need to all be added up together and set equal to 11. So I'm going to write those down here. I'm going to put 2x plus x minus 1 equals 11. So what we can do is we can combine like terms again. And I see x, a whole bunch of x's that can be added together. So 2x plus x gives us 4x. And then bring down the minus 1 equals 11. Now we need to get x by itself, so we need to get rid of the negative 1 with a positive 1. And you have to do that to both sides. So that becomes 0. Bring down 4x equals 12. Divide by 4. X is 3, because 12 divided by 4 is 3. And that's where I got that right there. So if x is 3, that means that's the number of silver medals. And put number of silver. Oh, we did part C and D together. So C was our equation, and D was actually solving the equation. So then it says part E, how many gold medals did Jamaica earn? and explain how you know. So we have to go back to the gold, and what it said in the problem was that gold had twice as many as silver. So they represented it as 2 times x, and since we now know x is 3, we can just plug 3 right here. So 2 times 3 gives us 6. So for part E, I'm just going to write it really small over here. They earned 6 gold. And if you want to explain it, in the problem, it says there are twice as many gold as silver, and we realize 3 is the number of silver, so plug it in, and you get 6 gold. All right. Okay, now 695, you only have to do part A, and then we'll do the learning log and be done. All right, 695. Okay, so it gives you word problems to do, but just part A. If you have time and if you want a challenge, you can do the rest. But it says you may choose to use the 5D process and create a table to build your equation. It may be helpful first to do 1 or 2 trials with numbers to help establish pattern. Whatever strategy you use, don't forget to define the variable by stating what x represents. Finally, check your answer. So let's look at 695A. Okay, a person's height is positively associated with his or her arm span, so the distance between the ends of your fingertips, if your arms are held out horizontally. One of the tallest men in history had an arm span measuring 7 inches more than his height. The combined total of his arm span and height was 221 inches. How tall was this man? So here's what I'm going to do first. I'm going to describe and draw. So I'm going to use some of the 5D process for this. So we know the tallest man is, his arm span. Tallest man arm span is 7 inches more than his height. His arm span plus his height equals a total of 221 inches, and it wants to know how tall is he. How tall is the man? So here's my table, and if you don't want to do a table, you don't have to. You can already write out the equation if you know how to write it. But I'm just going to do this for support. Okay. We only really have 2 things to define here. We need to define the height and his arm span. So I'm noticing that we don't know anything about his height. We just know that his arm span is 7 inches more than the height. So if there's anything in the problem that you really don't know much about, and it seems like everything's kind of revolving around that one, we're going to use his height as x, because we really don't know anything else about x, about his height. Arm span we know is 7 inches more than his height, so we can compare arm span to this x with x plus 7, because whatever arm span is going to be 7 more than his height. And then to do, we're going to have to, sorry, I missed this part. So we're in the do section, we're just adding them together. X plus 7 equals 221. Now we can start some trials. However, if you do notice that we have an equation already, you can probably solve it faster than I can do the trials. So I picked a number for x, I picked 100. And so this would be 100 plus 7, which is 107. And 100 plus 107 gives me 207. which was just a bit too small. So that didn't work. So I did a little bit more than 100. I did 105. So 105 plus 7 is 112. 105 plus 112 was 217. And that was still too small. So now I'm at the point where I'm like, okay, there was a spider. I'm at the point where I'm kind of tired of doing so many trials, and I kind of want to speed up this process. So I'm going to kind of abandon the chart. I'm going to take the equation that we have right here in the chart, bring it down here, x plus 7 equals 221. Now I can solve for x, and I don't have to do any more trials. X plus x gives us 2x, add 7 equals 221. Got to get x all by itself. Got to get rid of this positive 7, so we minus a 7. That becomes 0. 2x equals, this is 214. 214 divided by 2 is 107. So now we have our solution, which is 107. That means that the height, he is 107 inches tall, and his arm span, so let's see. I'm gonna put, I'm not gonna erase anything. I'm gonna put that his height is 107, so that means his arm span would be 114, because it's 107 plus 114. Okay. Last thing we have to do is the learning log, and we're kind of bringing all of this 5D process and equations together and talking about it or writing about it. So the learning log says, this is 696, titled Using the 5D process to write and solve equations. And the date, I'm putting 3/31. And it says, in chapter 5, you learned about variables and using the 5D process to solve problems. In this chapter, you simplified expressions using algebra tiles and focused on solving equations. In your learning log, describe how variables and equations can be used to solve word problems. Use an example problem to help make your explanation clear. Title this entry and label it with today's date. So, let me see. We kind of can use the last problem we did as an example, but here's how I started my learning log. Using the 5D process, comma. So the whole point of the 5D process is defining your variable. Defining a variable just means you label one part of your problem with a variable, and then everything else kind of revolves around it. And then you can plug it into an equation to solve for your variable. So I put you define your variable and how the other quantities relate to your variable. I put then you then decide what to do with the quantities. You decide what to do with the quantities, and that was part of the do section, and then set it equal to your given total, and then you can solve for your variable. And that is pretty much the gist of what the learning log wants you to know about the 5D process, how it relates to solving equations, defining variables, and that is going to be it for this lesson. Thanks for watching.